Imagine taking your car on a scenic road trip high up into the mountains, but the further you climb in elevation, the more your engine violently misfires, loses all its horsepower, and starts dumping raw unburned fuel straight out the tailpipe. You scan the dashboard and pull a P222F code, which means your engine computer has detected a serious correlation error between the A and B signals of your barometric pressure sensor. To squeeze maximum fuel economy and performance out of your engine, the computer has to constantly maintain the perfect stoichiometric mixture of exactly 14.7 parts air to 1 part fuel. Because the air gets thinner and less dense the higher you drive, the computer relies heavily on the barometric pressure sensor to measure the exact atmospheric pressure surrounding the car. I was actually just grinding through the tedious paperwork and data metrics for my Amazon influencer application this week, and it honestly reminded me of just how much relentless data processing your engine control module has to do every single second to keep you on the road. When the computer sees that the two internal signal circuits inside the barometric pressure sensor are giving conflicting atmospheric readings, it throws this correlation code because it no longer trusts the data, which severely impacts your throttle responsiveness and fuel trims. This is a moderately severe code that you should not ignore, because running an engine with a badly skewed air and fuel ratio for an extended period can cause massive internal damage or completely melt your expensive catalytic converters. You need to start your mechanical troubleshooting by physically locating the sensor under the hood. Unlike oxygen sensors that are bolted directly into the exhaust, barometric sensors are usually mounted right on the firewall or the intake manifold, making them highly susceptible to intense engine heat and vibrations. Meticulously inspect the plastic housing for hairline cracks and ensure that the tiny ambient air reference port is not completely blocked by accumulated road dirt. Next, you must verify the electrical integrity of the connector. Carefully unplug it, remembering to disconnect your battery first to avoid sending a fatal electrical spike to the engine computer, and check for bent pins or heavy corrosion. Grab your digital multimeter, pull up the specific factory wiring diagram, and verify that the reference voltage and ground circuits are solidly within the manufacturer specifications before condemning the sensor.